Closures in JavaScript is a very important concept and unfortunately one of the most underlooked ones. This video is a follow-up of my previous video where we discussed the concept of hoisting and developed a mental model of JavaScript execution. If you haven't checked this video, I would highly recommend to checking this out first. Link to the same will be present in the description titled JavaScript Hoisting Execution. So let's get into this. What we have is an interesting example in front of us that we are gonna dig today. So grab your popcorns, no, a screenshot of it so you don't get lost along this way. I want you to ponder for a while and think what will be the output of the code block. And the output, without any surprises this time, is up, as you can see in the console. Now, if you think about what we previously discussed in JavaScript execution lecture, the top execution context gets destroyed when we are done with the function, which means when getStatus function is called, the value of status that was in the scope got destroyed as well. So how in the world, when we called the getStatus function at the end, was it able to retrieve the value of status variable that is nowhere to be present? That was a lot to digest, so let's go step by step. First, our function declaration will get hoisted at top. The second declaration, as we see here, is a const one, so lexical hoisting, which is in temporal dead zone before the execution of its declaration. And when this function is called, it will get added to the call stack, and our call stack will immediately put it in the thread of execution. And now the execution begins. So everything is fine till now. The status gets initialized after its declaration, and the getStatus function is hoisted. It is when the getStatus function is created, a backpack gets created. Not because the JavaScript engine executed the code, but it does something called static analysis to pass into this backpack only the declarations that it is using, which means the declaration of getStatus function or any other variable, if have been there, would not have been passed to the backpack. Let's go to the editor and see what I mean. So we are here in our code editor. On the left, what you are seeing is the code example we were just working on. On the right, you are seeing the terminal which we will use to execute commands. And the command you are seeing right here is node inspect break closure.js. Closure.js is the name of the file where this code resides, and the argument inspect break. Now, what this argument does is activates the debugger and opens a port with WebSocket protocol on our local host so we can debug our application. So Chrome provides a dedicated DevTools for testing, for debugging our Node.js application. That will look something like this, which you can access by visiting this URL, Chrome inspect, and going to the devices section and clicking on this open dedicated DevTools for Node. It will have a default connection for port 9229. In case there is no connection there, you can simply add that. Now, here we go. So the debugger is listening on WebSocket connection on this port number that DevTools were listening for, and the debugger is attached, which means we can now debug our code here. So debugger is paused right now because of the break argument we put in here, and we will use this button here. You can hover over them to see the title of the button. So it's the step button that we will use to go one step ahead in our code. Right now our execution will call this getStatus function, and we will move a step ahead. So as you can see, we are in the getStatus function here. This is the local scope of the getStatus function here, and status here is hoisted, and the value is unavailable because this line has not yet executed. And non-used is the var declaration that is hoisted to the value undefined. This is called declaration hoisting. And the getStatus function is hoisted as it is because it's of the function declaration. Now what I want to show you is in the getStatus function, you can go into the scope section and see in the closure that there is status. So The code has not executed yet, but our JavaScript engine has parsed this code and it knows that the code inside getStatus function will use the status from its parent. So it has already put this status in the backpack of this getStatus function here. So after the execution of the declaration, you can see that this value will get updated to up. So it's a common misconception to think that the backpack gets created only when the outer function like getStatus function will return it. The backpack is created at that moment, but no, it is created at the moment when the function is created. So it's something done by JavaScript parser. So that's why it knows which variables to pass into this, because there's another variable like non-used variable here that is not the part of the closure. So how does it knows before the execution of getStatus function? That is because it does a static analysis. The JavaScript create engine does static analysis inside it, and it knows which variables will it use from its lexical environment or parent environment. So that's all I want to show you here. Now let's get back. And this behavior of having a persistent reference to the variables of parent scope or lexical environment is what we call as closure in JavaScript, and is created at the very moment the function was created. Moving on with the execution, the getStatus will now be called and be put in the call stack, from where it will be moved to the thread of execution, where we will now continue with its execution. As you can see, the getStatus function returns the status variable, which was declared in the execution context of getStatus function that was just destroyed. So here comes closure to the rescue and says, here is something left by your parents when they were dying because they thought you might need it one day. So parents in JavaScript take good care of their children. Now, from its lexical surrounding, it obtains the variable status, and that is how lexical scoping works, in which the parser resolves the variable names when functions are nested. And with that, the execution of this function call comes to an end, and the value up gets returned as an argument to the console.log function, and the log function will again go to call stack and get executed, which will result in up getting logged to the console. With that, our process or program comes to an end, and at this time the operating system itself will reclaim the memory that was allocated to this process. I hope you now have a decent understanding of how closures in JavaScript work, along with a brush up on execution as well. With that, I would like to wrap up this session, and if you are for the first time here, hit that follow or subscribe button because it really helps me to stay motivated, and these videos take a lot of effort. And do let me know about your thoughts on this. Stay tuned for next post. Thank you for your time.